even and odd function. So even function, every time I think about even function, like every time someone say even function to me, so when someone say even function, what I am thinking is a parabola, f of x equals to x squared. This one, parabola. So the graph, this is the graph of a parabola. So what is an even function? Even function is y-axis symmetry. Y-axis is right over here. Y-axis symmetry. And then the characteristic of an even function is if you replace x with negative x, here, right over here, do you see a big red negative? When you replace x with negative x, you will get back to the same function. So for the parabola x squared, here is a quick test. I replace this x with negative x. So on the right hand side of the equal, we have a negative x as well. But once you square the negative x, you will have an f of negative x equals to x squared. So we just get back to the original function. So therefore, f of x equals to x squared is an even function. For odd function, when you change the x to a negative x, you can pull the negative out. It looks like factor, but the word factor is incorrect to use. You can pull the function, you can not put the function, you can pull the negative out of the function. So the character graph is origin symmetry. Origin symmetry is the graph exists either in quadrant 1, quadrant 3, it's like just like a diagonal, quadrant 1 and 3, or quadrant 2 and 4. For even function, the graph exists either in quadrant 1, 2, or quadrant 3, 4, either 1, 2, or 3, 4. Origin symmetry is either 1, 3, or 2, 4. So the typical example is f of x equals to the cube root of x. Another good example is f of x equals to x to the third power. Alright, replace x with negative x. So this is, we have f of negative x equals to the cube root of. So you have a negative 1. And then you have an x. So the cube root of negative 1, what is that equal to? Negative 1, right? Because negative 1 times itself 3 times is equals to negative 1. So you have a negative, the cube root of x. See? We just pull the negative out. So that's why the cube root of x is an odd function. Now, we mentioned x-axis symmetry, origin symmetry. What about x-axis symmetry? X-axis symmetry, take a look at the red. Right over here. X-axis symmetry is not even a function because the vertical line test failed. What do I mean by vertical line test failed? You draw a vertical line on this sideways parabola, you see exactly two intersections. What does that mean? That means for some x value you choose, you will get two different y values. So the one-to-one property is not satisfied. The best examples to use is f of x equals to plus or minus square root of x. The plus square root of x is the piece in the first quadrant. The minus square root of x is the piece on the fourth quadrant. So this is x-axis symmetry, which is not even a function. And then is the function is always odd or even? The answer is no. Sometimes it is neither not odd nor even. The perfect example is f of x equals to 2 minus x. It's a straight line, is neither odd nor even. So if you replace the x with negative x, like that, f of x equals to negative x. I should save myself some space. What do you have? You will have a 2 minus negative x, which is a 2 plus x. So there is nothing else you can do like here or here. You can't do this thing. So that's why this straight line 2 minus x is neither nor, not odd nor even. Okay, more examples to do. So this time, okay, what's the first one? The first one is f of negative x equals to 3 times negative x to the 8th minus 2 negative x to the 4th plus 1. So they are even power, they will just get rid of the negative. So f of negative x is equals to 3x to the 8th power minus 2x to the 4th power plus 1. So this is even, right? And then how about the purple? F of x equals to x times 5 minus x squared. Replace the x with negative x to do the test. We have a negative x and then we have 5 minus negative x squared. So the negative inside the square root is gone due to the square. So therefore, we have this f of negative x. We have a negative 1 equals to negative 1 and then times x square root of 5 minus x squared. So we pull the negative 1 out. So now we have negative 1 times the entire original function. So therefore, this is an odd function. Okay, how about the grade one, x? How about we change the function a little bit? Does that change a lot? So we have f of negative x equals to negative x and then 5 plus minus x. No, this is nothing. So f of negative x is equals to negative 1. You can do a negative 1 like that, and then x, this becomes a 5 minus x, not the original function anymore. So this is neither. How about the green one? So the green one, we have g of x, negative x, right? Negative x equals to a negative x 3 over 2. All right, so 3 over 2. Okay, I will just do it like this first. And then negative x, if this is 8, then we have a square root of negative square root. The over 2 becomes a square root, and then this is a third power. Do we get anything? You can't even get the x out. You can't even get the negative out because it is in a square root. So this one is neither. Let's do the last one. The last one is 8, right? So I'm going to write this down first. K of x equals to 8 x 2 over 3. Okay, let's do the work. So we have k of negative x equals to 8 times, will be the cube root of negative x, and then we have a 2. So this one we can pull the negative out because the cube root of negative 1 is equals to negative 1. And then this is 8, and then we have a cube root, we have a negative 1 multiply x, and then we have the whole thing square. So we can pull it out. After we pull it out, then we have 8 times negative 1 multiply the cube root of x, and then the whole thing square. And then once you square the negative 1, you have 8, and then this becomes x to the 2 over 3. So we just get back to the original function. So k of negative x is equals to the original function. Therefore, that becomes even. And then what is the graph of the last one looks like? The graph of the last function looks like this. So one piece goes up like that, the other piece goes up like that. Let's make it nicer. The other piece goes up like that. All right, so that is the end of this video. Simple lesson, not too difficult. If you like it, give me a thumbs up, subscribe. Truly appreciate your subscription to my channel. See you next time.